Hello, I'd like to welcome everyone to ARP's first event in our 3 days Digital Horizon series, exploring how digital, data and AI can help us achieve meaningful climate impact.
AI. It's a topic that's exploded in the public's consciousness after the launch of ChatGPT 2 years ago and has dominated media and conference headlines since. But much of that debate has felt frothy and unconnected to a more honest and impactful conversation about what AI can and cannot do in the built environment world we all operate in. For example, at Arup, for a while now we've been all in on developing real-world AI that can bring tangible benefits to the work we do in cities, in infrastructure, in property, energy, nature and beyond. We're already using machine learning and large-scale satellite data to design city infrastructure and investments that benefit citizens with lower carbon and greater nature, such as a major program of urban gardens in Mexico City or planning an urban forest surrounding Tirana.
The AI for Healthy Cities initiative in Novartis is basically putting together groups of data sets at a high level, basically, and trying to predict cardiovascular disease and determine from within the macro built environment the health of populations from poorer areas to more wealthy areas, and looking at these disparities. And that takes in data on mental health conditions, depression, stress, anxiety, substance abuse, social needs. It's linked to the hospital EHR systems to understand concerns around, paying bills, housing conditions, that kind of stuff as well. And AI here is helping to identify those determinants of health. And this helps us with city planners and macro level digital twins to actually look at public planning and thinking about how we design cities for the future so that people don't get left behind, and the use of AI or the impact of AI is equitable for all.
Most people in Hong Kong live in multi-story buildings, and renovation noise is indeed a large problem. In many situations, we assess the renovation facts. We cannot get inside. We do not know what type of equipment involved in the renovation, because we would like to control some specific type of equipment, like large handheld breakers, for example. So we are developing an AI mobile app. Complainants do not know whether such equipment is involved, but with that AI mobile app, they can measure noise outside the renovation flat, and the AI could tell them how likely the large handheld breaker is involved. Do they need to report that case to us for follow-up actions? And without this AI, the enforcement of such legislation cannot be proceeded.
Really, when you get down to it, what we're doing with AI is about trying to make the right decisions at the right time in a landscape we've just got increasing complexity all the time, as with decentralized renewable energy systems. So a lot of our AI right now is focused on just making each of those decision points that we face faster, more accurate, make them learning where traditionally they haven't been. So things like national demand forecast model to forecast how much energy Great Britain will demand per half hour using quite advanced transformer technology, a confluence of generative AI and traditional AI. And that model is proving to be something around about 60% more accurate than the one that we're using today.
I'm going to be provocative and say that a lot of the data science and AI is eminently doable. It's the domain understanding that makes the difference between a kind of nice idea and a deployed functioning product. Bringing the people who are going to operate the model, deploy it, use it in practice is absolutely critical. We've been involved, along with Network Rail and City University, in a digital twin of a bridge in Staffordshire. Detecting structural change has traditionally been done with audio techniques, but it's actually quite hard to detect small-scale early-stage damage. This bridge, it's been built from the get-go with sensors inbuilt. It matters as much to show that the technology is working, but almost more importantly, that Network Rail, the engineers, embrace this and see this as useful, value for money, practical, because otherwise it won't reach scale and won't be adopted. So I would say a mistake often made by technologists is to think that the only bit that matters is the algorithms. There's a lot of, you can't find the right problems or solve them effectively or get them adopted if you've not got that domain expertise.